Hi, everybody at home. You'll get used to that. If you would, pause the video and copy down that. Anyway, do you want to say hi? Say hi. Did I get you? Did I get you? Everybody want to say hi? Wait, does everyone approve to be on? Yeah? Wait, you can shake your head no? No? Yeah? We're good? Oh, everybody say hello. Wait, there it is. There it is. Yeah, okay. Anyway. All right. Dilutions is not a new word for you because you know that if you dilute something, you add more solvent. If you concentrate something, you add more solute. That's vocab from lecture 1 of the unit. But diluting can have a quantitative component also, because when you dilute something, you want the molarity to drop. That's the whole point. All right, you're basically dumping more solvent, which is usually water. So by adding more water to a solution, the molarity goes down. It becomes safer to use. You don't just randomly dilute, though. All right, you don't say, well, cool, well, I don't want the molarity to be 10, I want it to be 4, so I'm going to dump water and keep my fingers crossed that it becomes 4. No. You use an equation that perfectly can dilute any molarity down to, it's always downward, the molarity that you want. Of all the equations that we use during the school year, the molarity and the dilutions are the ones that I work with most often. So the M1V1 equals M2V2 is very close to my heart. And here's why. Whenever I order chemicals, all right, the company I order from is a thing called Flynn. When I use my budget money and I start ordering all the fun stuff that I give y'all to experiment with, they send me high concentrations of it. For example, sulfuric acid is one of the most dangerous things I order. I've used that example here before. When I order sulfuric acid, it comes in this size. All right, this is the size bottle that they send me. All right, this one's empty. But they send me 18 molar sulfuric acid. Is that a high or low molarity? I told you recently that once you get like above 7 molar, it's considered strong. 18 molar is almost 3 times that. That sulfuric acid is destroy you sulfuric acid when it comes in this bottle. It's actually illegal for me to bring that stuff in the room with you. I already told you that I have to label the molarity of everything, but if I were to pour some of that 18 molar into a beaker and label it 18 molar, I would be doing the labeling part that I'm required to do. But if someone saw that I was letting you handle that, I would be deemed a danger to you. Because if you spill that over on one of your classmates, you can't fix it. All right? They will remember that for their whole life, even if it just gets on their skin. So why then? Why does Flynn send me such dangerous stuff? They could dilute it before they sent it to me. The reason they send me something this size of 18 molar sulfuric acid is because it's really good bang for my buck. Yes, I don't let you handle the 18 molar, but whenever I need to make you a solution that's like 2 or 3 molar, I just have to take a little bit of that, add water to that little bit I took out, which gives me a lot of it, and it lowers the molarity to what's useful in lab. And it only used a little bit of my stock solution. How do I know how much to add? The dilution equation, M1V1 equals M2V2. So I suit up because this stuff's scary. But I do the calculation. I'm like, okay, well, if I need 2.5 molar, I can plug in the numbers of what I need and figure out exactly how much of the little bit of this I need and how much water I need to add to it to make the 18 molar sample I've poured out drop down to exactly what I want you to use. Very, very handy. Now, the 1s and the 2s in M1V1 equals M2V2 are not numerical, that you don't like put those in the calculator. It's referring to the before and the after. This is the starting molarity and volume of the stock solution. And this is the ending molarity and volume that you want to turn it into by adding water. So, for example, if I was using my 18 molar, here's what the numbers would be. You don't have to write this down, but the starting molarity would be the 18 molar, because that's what's in my stock. I would be looking for the amount of that I need, because what I usually know is what molarity I want and the amount I need. Like maybe I need 800 liters. I figure out how many lab groups there are over a lab, and I'm like, all of my to serve all the groups that are going to go through this lab, I need 800 milliliters. So I'd be like, all right, so I need to end with 800 milliliters, and I want 2.5 molar, making that number up. And I start with 18 molar. If I plug those three numbers in and solve for V1, it'll tell me the exact amount of this that I need to pour out as starting, and then I would add water up to 800 mils. Anyway, my point is that this is super useful, very real life, and I want to show you how to calculate it. All right, we're going to do 3 problems today. It's going to be just like the molarity lecture. I'm going to have you write down the questions for the first 2. You won't have to write the question for the last one. And I bet we'll finish early. Sound good? Okay. So then if you would, please copy down that first question. Also, copy down my outline for a dilution problem up here. This skeleton will help you not get lost in the words of the word problem. Here's the thing. M1V1 equals M2V2 is very easy to use. The only reason that dilution questions have the potential to cause you problems is because the context can move around different parts of this setup. So my advice to you is to draw these. You don't have to, and y'all might just be good enough not to need to. But you'll see that this is the setup of any dilution. And if you apply the word problem to it using its context clues, you won't get mixed up on what numbers it's giving you. Here's what you're looking at, though. These are not 2 different beakers. They're the same beaker. It's just a before and after. This is the starting beaker, and then we dilute it. We add water to it, and it becomes that beaker. So now we just label the descriptions that it gives me. It says, what is the molarity? So we're going to be finding a molarity that is made by diluting, adding water to 60 mils of 2.75 molar. Look what it described. The item that we're going to dilute is present at 60 milliliters, right? That's that line right there. And the strength of it is 2.75 molar. What are we diluting it to? 350 mils, which means when you add the water and this line moves up, of course, the resulting volume is 350 mils. The question wants to know, what's the molarity? What's the resulting strength? And it's very easy to find. We'll do it in a moment, but first, real quick, this isn't required, but just so we're being smart about it, how much water did they add? How much of the H2O must have been dumped in for these numbers to work? 290, right? So get a understanding of what we're saying. If you start with 60 and you dump in some water and you end up with 350 mils, the amount must have been 290 mils, which again is not required for the math we're about to do, but it's nice to have a clear view of what happened. All right, and to find that number, we subtract it, right? If you subtract the final minus the initial, it would give you the change. But anyway, let's plug and chug an answer. My starting molarity was 2.75. My starting volume was 60. My ending molarity is what we're solving for. Totally. You want to come take it over here for the camera? Okay. The ending volume was 350. And you should be able to solve pretty easily from there. Simplify the left to get 165. Simplify the right. Divide to isolate. Watch your sig figs. If you go back to the original problem, the values have 3 sig figs, 3 sig figs, 4 sig figs. So the smallest sig fig value is 3 for a final answer of 0.471 molar. And the conclusion makes sense on what we were doing there, right? We started with 2.75 molar and we dumped water on top of it. And you know, anytime you dilute, the solution becomes safer to handle. The molarity drops. And that much dropped it to 0.471 molar. Let's do another one that words it a tad bit differently. So make sure you stay focused so you don't get confused later. Please copy down question number 2. I also drew my skeleton dilution setup, which is always good to add. We're still going to do this one together. All right, so again, these are the same beaker, just before we added water. This is after we added the water. Let's see how it describes the situation. What concentration, which is just a synonym for molarity, so what molarity would result by adding 100 mils of water? Look what it just told us. Didn't give us that value last time. It's flat out saying you're going to add 100 milliliters of the water. What are you adding it to? 65 mils of 9.7 molar. 65 mils. That's the amount of 9.7 molar. That's pretty strong. And it wants to know, what is the concentration? What is the molarity again? Do we have M2 or V2? We do have V2. That's what it wants you to be able to do. It wants you to be smart enough to know that they are dumping 100 mils of water onto 65 mils of water. So what is V2? 165. This number's there. You just had to think an extra 2 seconds to find it, which again is why I think the pictures help. And now it's the same dang thing. Your starting molarity is 9.7. Your starting volume was 65. Your ending molarity is unknown. Your ending volume was calculated to be 165. Usually if you misuse the context rules here, you would find a place to put that 100 in the equation where it doesn't belong, so careful, careful. Find X. I'm going to draw a card. Solve it. Did Aspen end on you? Or did I not? It did, right? I mean, I've got, oh, 4-4. Psh, I'm stupid. You have Aspen right now, right? It moved, right? I knew something weird happened just here. I'm only drawing this one card, so I'm not going to throw it out at you, but you've got Aspen. Just in case it's you. Let's draw that card. Watch your sig figs. Let's go over to cluster 6. Oh, it might hit you, Aspen. Seat 3. Hey, Aspen, what'd you get? Yeah, you got the right calculation, but not 3.82. What did y'all put? Yeah, just 3.8 molar. Because we had 2 sig figs, 2 sig figs, 3 sig figs, so we had to only use 2 sig figs. Oh, but it didn't. You're 6'1", not 6'3". but I believe you. All right, so want to do one by yourself and call it a unit? Don't copy the question on this last one, but I want you to notice it actually asks you to do two things. So do them both. Good luck. I know it looks longer, but it's the exact same stuff. I'm about to move. It's all these people at home causing problems. You should be in class. Why are you even watching this? Remember, try to answer both questions. The first question is looking for one of our normal values that we were finding. The second question is looking for this number.
Not jump or straw on the floor.
It's gonna be like the Applewood now.
I went to the water fountain, filled it up, and then I dropped the straw on the floor on accident.
Well, why would you put the straw back in? You could have just told me I would have just drank out the hole.
Did you rinse off the straw though?
Yeah.
Oh, you rinsed it off. Oh, well, I know that part.
You're leaving out key details of the story.
But I just thought it would be funny if I just said I dropped the straw.
It was funny. I'm gonna slide the whiteboard to show you my work. If you're still working, don't look at it yet. If you have differing data than me, ask. Let's talk about it. Here we go.